Hi everybody, this is Mr. Short. Today we're going to be doing two things. First, we're going to start off by comparing and contrasting physical change versus chemical change, and then we're going to continue on with talking about two different lines of evidence that suggest that a chemical reaction has happened. First, let's start with physical versus chemical change. So first of all, this little triangle in science means change. It's the Greek delta symbol, which means change. So a physical change is defined as a change in physical appearance, and this includes a change in state. Now I've included three examples here. The first example is a change in state. You can see it's water beforehand and it's water afterwards. You just have a change in state. It starts out from a liquid, as a liquid, and it changes to a gas. So of course the type of change that occurred here is boiling. Boiling changes a liquid to a gas. Some other examples of physical change would include breaking or tearing. And also, this is one that's tricky for students. Dissolving is also an example of a physical change. Here's the reason why. The general test that you do to figure out if it's physical versus chemical is to ask yourself, is there something that I could do to undo that process or to recover the original components of the reaction? And if you think about dissolving, you could have water, and you could have solid table salt, and you could put the table salt into the water and mix it up. Now it looks like the table salt is gone, but we could recover that table salt by boiling the water. We could even collect the water and condense it back into liquid water. So for that reason, dissolving is an example of a physical change. Okay, same thing here. The test again is there something that we can do to kind of undo that process and recover the original material? So if we have gaseous water, we could condense the gaseous water and turn it back into liquid water. For breaking and tearing, there's not really anything that we can do to easily undo those processes. But if you think about like tearing paper, it's paper beforehand and it's also paper afterwards. All right, changing gears and thinking about chemical change. So chemical change is defined as a change in the chemical composition of matter. And I've listed two examples down here. So the first example is burning. Remember, burning typically means combustion. So if we have propane, C3H8, and we react it with oxygen, diatomic oxygen, to make carbon dioxide and water, this is an example of a combustion reaction. See how the reactants are changed into different products. Okay, and there's nothing that we can do to easily undo this process. Here's another example. Rusting is another example. So we could have native iron, react it with diatomic oxygen, and it will rust or oxidize to form what's actually called iron 3 oxide. So remember, the 3 in iron 3 oxide tells you the charge on it, not the number of irons in the chemical formula. But again, take a look. See how the reactants have different chemical compositions than the products. Okay, for that reason, rusting is an example of a chemical change. Now remember, the test that you do to distinguish between physical versus chemical change is to ask yourself, is there something that I could do to undo this process? There's no undoing these processes here, but in dissolving, there's something that we can do to undo that process. In boiling, there's something that we can do to undo that process. And then in these examples here, it's, say, paper beforehand and it's paper afterwards. Or if you think about breaking a vase, it's ceramic beforehand and it's ceramic afterwards. There's no change in the chemical composition. Okay, so again, the concepts here are distinguishing between physical and chemical change. Okay, you can see throughout the bulk of the notes that we're going to be doing some color coding. The guiding question right up here is, list and describe evidence which suggests that a chemical reaction has occurred. And I said, evidence which suggests that a chemical reaction has occurred, it comes in two forms. You can have a change in energy. We're going to explore that up top. Or you can have a change in matter. Okay, so up top in this section, we're going to explore changes in energy. The first type is a change in temperature. So if you take a look at the first reaction, we have zinc, which is a metal. It reacts with an acid, hydrochloric acid, and it forms bubbles, hydrogen gas. forms zinc chloride, and it also releases heat energy. Now, because heat energy is a product, it's on the right-hand side of this chemical reaction, heat energy is therefore given off, and so we would have an increase in temperature. When you have an increase in temperature, that's called an exothermic chemical reaction. So exothermic, I'm going to go like this, increase in temperature. In contrast, this is going to be an endothermic chemical reaction where heat energy is consumed. Okay, you can see that it's on the left-hand side of the chemical reaction. So this is endothermic. And in endothermic reactions, you would have a decrease in temperature. Now, a lot of students struggle with this concept right here because they see heat energy and they think, oh, well, if heat energy goes into the system, then the temperature must increase. But actually, the role of heat energy here is to break a bunch of these bonds that are right here. Okay, so remember, if the temperature change increases, it's exothermic, heat is given off. If the temperature decreases, it's endothermic, and heat energy is consumed in order to break bonds within reactants. All right, you could have a change in sound also. So here I've got diatomic hydrogen gas plus diatomic oxygen gas makes 2 water molecules, and it tends to make a popping sound. Now, sound could be an indicator that you have a chemical reaction going on. Not always, but sometimes. You could also have a release of light. So if you take a look at the reactants in the products, the reactants and products tell us that this is a combustion reaction. And we know that combustion reactions are always exothermic. They always release heat energy, and they give off light. So light is also a pretty good indicator that you've got a chemical change going on. Not always, but sometimes. Okay, so again, we've got a couple classes of changes in energy that you can look for to determine if a chemical reaction is likely occurring or not. The second category, though, is changes in color. So here, if you take a look, we've got 2 magnesiums reacting with diatomic oxygen, making 2 magnesium oxides. This is a sparkler like at 4th of July. So the sparkler comes on a metal stick, and it's got kind of a grayish material that's on there. And it glows this blinding white light, and it makes a chalky white substance afterwards. So because there's a change in color, that's a pretty good indicator that there's a chemical change. So I'm going to put silvery metal, and on the product site, I'm going to put chalky white. Again, because there's a change in color, that's a pretty good indicator that there's a chemical change. All right, the next is formation of a precipitate. So precipitation, just like outside, rain, sleet, snow, hail, falls from high to low. It falls towards the ground, and precipitates in chemistry fall to the bottom of the reaction tube. So you can see we have silver nitrate in the aqueous state, and sodium chloride also in the aqueous state, and it makes aqueous sodium nitrate, but you also get this solid silver chloride. And the silver chloride will precipitate out of solution because it is solid, and it'll fall to the bottom of the reaction tube. So I'm going to put white precipitate, falls to bottom of tube. Okay, the next one is formation of a gas. You can see I've highlighted the gas on this side. So whereas we start with a solid and a solution, an aqueous solution, and we get an aqueous solution, a gas, and a liquid, production of a gas which bubbles is a pretty good indicator that a chemical reaction is occurring. So I'm going to say up here, look for bubbles. Also note that NO2 is smelly. If you produce an odor, whether it's smelly or pleasant, that's a pretty good indicator that you've got a chemical reaction going on. So I'm going to draw an arrow up there. So 3 and 4 go hand in hand. Okay. All right. So again, this is about changes in energy state or changes in matter that we can look for that suggest that a chemical reaction has occurred. All right. Thanks a lot, guys. Have a great day.